It's just a pattern you have to know.
Oh, pattern.
Thank you. Let's start with, I think, easy warm-ups. X squared minus 25.
Are we solving or factoring?
That's a great question. Based on that picture, or based on that statement,
That looks like factoring. That's a silly question.
that's a factoring problem, not a solving problem. Because there's no equal to on there. I'm good.
You just froze.
Yes, is exactly what I was doing, writing a problem. There we go. 3, I think, relatively easy ones, but maybe you disagree. This morning. All right, there's one half new thing and one definitely new thing. A plus 7 squared minus 16. Let's factor that. You know what? I should have done it this way. I got something squared minus 16. And I want to factor that. So look at number 1 in the warm-up. Something squared minus something else squared.
Can't you just get rid of the square and get squared plus 49?
Well, this is not a squared plus 49. That is not a squared plus 49.
Would it be a plus 7?
No, it's 8 squared plus 14 plus 49.
It would be a squared plus 14a plus 49, but I don't want to do it that way. This is a difference of squares. Karis, you yelling at me here. Go ahead.
Move the 16 over and then take the square root.
Oh, no, I don't want to do that. I'm sorry. I shouldn't put the equal sign there. I want to factor that thing. So what you said was right, though. If that was equals 0, then we could...
Would we just take the square root? Would you take the square root of 16 and put it in?
No, just root a plus 7 plus 4 and a plus 7 minus 4.
There it is. The pattern is the first thing minus the second thing and the first thing plus the second thing, where the things are squared. I don't know. A plus 7, I don't know which one you want to do first. It doesn't really matter. Minus 4. A plus 7 plus 4. It's still a difference of squares. Now, we could clean that up a little bit and get A plus 3 and A plus 11.
Do you have to do that?
Yes, I would like you to do that.
Honestly, that's way easier.
Yeah, I think that's easier than multiplying it all out, subtracting 16, and then looking for...
So no wonder we have 51 probably.
I would have seen that if I was along.
All right, you try that one. We'll do one more of those. B minus 3 squared minus 25.
Are they always going to be that easy?
No.
So, still difference of squares. So you kind of know that one. It's just different with that first term being a squared term already. Looking different. All right, the definitely new thing is sum and difference of cubes. This one will be a pattern. This one will be a pattern you have to memorize. There's not really a way to figure this one out. This is just a new way of factoring that you'll have to memorize. So if I've got x cubed minus a cubed,
Wait,
they're both cubes now. They're not squared. Squares was pretty easy. X plus a, x minus a. Cubes, it'll kind of start the same way. X minus a. But the rest is, again, it's a pattern that you'll have to memorize. You'll have to know this pattern. That people put all sorts of wrong answers coming next.
Was that right?
Nope. X squared plus ax plus a squared. And that's why people need to memorize the pattern, because it's not x minus a times x minus a times x minus a.
Could that be
Right, they'd have a whole bunch of AX terms in the middle of it. This one, the AX squared and the A squared X, all those terms end up canceling out because of the signs. So if we did multiply this all out, we would get back to x cubed minus a cubed. There is a little bit of a hint on this that helps, and that is the signs. This sign is the same as the original sign, like if we start with minus, this one's the same. So that one's always the same as what you started with. This next one is always opposite of what you started with. And that last one is always positive. So if you take same, opposite, always, positive, it spells out the word soap. So soap is nice, but soap only tells you the signs. So don't get, if all you remember is soap, I got it. You're like, well, yes and no. Soap tells you the signs, but it doesn't tell you, what goes where. Yeah, so it's a help, but it's not everything. Let's do x cubed plus a cubed. Okay, this is a significant difference from the cube or from squares, because with squares you couldn't do sum of squares at all. You were just stuck. But you can do a sum of cubes, and it follows the same pattern. So if it follows that same pattern, what do you think the first factor is? X plus a.
Are we going to get numbers? A would be x squared plus, x squared minus ax.
X squared
A squared.
minus ax plus a squared. So the other good thing about soap is it differentiates the two. Everything else about the two is the same. Xa, x squared, ax, a squared. But soap will keep them apart. Let's do an actual problem here. X cubed minus 27. So the first thing we recognize is, are those perfect cubes? Yes. X cubed is obviously a perfect cube. 27, also a perfect cube. So what's going to go in this first blank, do you think? X minus 3. A lot of times I'll do the soap first to sort of set up what this should look like. So same, opposite, always positive. Then it's square the first one, x squared, plus multiply the two together, 3x,
Plus 9.
square the second one.
Oh shoot, but now we have like a square term.
What that's the square times 3. This would be 3 times 5.
Square the first, multiply the two together, and then square the second. Oh, that's a good point. Now this looks like it will factor.
It won't.
It won't.
It will never factor. So don't spend your time sitting there looking and thinking, all right, well, what multiplies to 9 and adds to 3? Nothing. It won't ever work. The second thing will never factor. So you don't have to worry about, it looks like it, and we told you yesterday to always keep looking because you might be able to factor something else. If it's a sum or difference of cubes, you'll end right there. It's as good as it gets.
That makes it easy though. You don't have to factor extra.
That's right. Yeah, that's it. There's nothing else to do.
Homework.
So if you were to solve, you'd have your x, and then you'd have
If you were to solve, first you'd need an equal 0 over here.
yeah,
So one of your answers would be 3.
and then one of them you'd have to graph or whatever.
You'd have to use quadratic formula because you're going to get imaginaries. You would get imaginaries every time.
I don't like
There's going to be 3 answers.
That would give you 3 answers, which we would expect from an x cubed. In fact, if we backed up and said x cubed minus 27 equals 0, everyone would get x equals 3. And you would think that's the only answer, but there are 2 more imaginary answer.
Wait, why do they have to be imaginary?
Because you could cube it.
Because it could be -3 squared.
You can take the imaginary. You get
I said we go to homework.
I say we do one more and then we'll go to homework.
Okay.
8y cubed
Okay.
plus 125b cubed.
Well, why is there a B?
You know what? Let's make it b to the 6, just for fun.
No.
Okay, who said that?
Okay, so the first question is, do we recognize that both of those are perfect cubes?
No, I didn't know. Actually, yes.
No, yes.
8.
8 is 2 cubed. Y cubed is y cubed.
Yeah.
Where did 125 come from? 5 cubed. How about b to the 6? B squared. So our first factor is always the cube root of the pieces. So it's always pretty easy to get started. You kind of answered this already. 2y plus 5b, how many? Squared. Because if I cube a square, I get a 6. And then, then I'm going to set up same, opposite, always positive. So it's minus and plus.
So it's y squared.
So I need to square the first term. So what happens when I square 2y?
What are we, 4y squared?
4y squared. Make sure you square all of it.
The whole thing.
You square that whole first term, 4y squared.
4 minus.
Because I didn't just square the y, I squared the 2y.
10y
No, it would be
squared.
10b squared y.
Both of y'all are right. You said the variables in a different order, but that's fine.
Let's go, Cooper.
2 times 5 is 10. And then I don't know which variable you should put first. I'm going to go yp squared.
Wait, why are you multiplying?
Because that second term is always multiply those two things together.
Okay. And then you
You square the first one,
25.
you multiply the two together, and then you square the second one.
25 to the 4th.
And so when you square 5b squared, you get 25b to the 4th.
This is
What
hard.
was the first one?
These are the cube root of these. So job 1 is to recognize that both of those are perfect cubes. When you do that, then you take the cube root of the first thing and the cube root of the second thing, and then you're off and running. If it's not perfect cubes, then you can't use this method. It's sort of like
Is there more?
if you want to do difference of squares, but it's not squares, then you're stuck.
What's the real world application?
If you want to do difference of cubes, but they're not cubes, then you're stuck. So we were probably not going to give you problems like that because there's nothing you can do to factor them.
Just no solution.
Just go with one of those, just to see.
Would it just be no solution?
Well, it's not no solutions because I'm not asking for solutions.
You did.
No factors I would take.
Okay.
You could quadratic formula the first one if you were looking for solutions.
What's the real world? Yeah.
Real world application for factoring cubes. Ooh. I think I'm going to resort to there are times in life when you have to know a process and you have to be able to prove to there's not a real good answer to that
So we should
that I know of. That I know of. I'll put that on there.
Or it's going to be an Alg2 teacher.
That's right.
I don't know. Wait.
Hey, don't knock it till you tried it. Yeah.
Did you do factor cubes in engineering?
A lot harder.
I don't think so.
Are we gonna need this later?
You still have to know it for this thing.
That's right. The application is next week on Tuesday.
But after this test, I can just forget it.
No, because you will need to factor cubes further in high school. I know that's not much of a real world application, but you will need to know how to factor those. So I'm going to be able to add 51 problems to my total and your total.
Are we doing all 51?
Kinda.
Oh, kinda.
We'll split it up odds and evens. So yes, but over 2 days. So, or you could go front back. I don't care.
It's all going to have to be finished.
It's all gonna have to be finished, and we're working on it today and tomorrow. So if you want to go front back or even odd, mix it up a little bit.
I'm just gonna do it all today, so we don't have to do it tomorrow.
You can do it all today and then not have to worry about it tomorrow.
We're not taking the H anything tomorrow.
And just to make it an even 50,
You should cross.
23 looked terrible, so I was like, let's just cross 23 out.
Yeah. Oh, I agree.
I bet it's 49 though. I bet it's, yeah, it's got to be 49 squared, right? To make 98, and
I don't think it matters.
it's already crossed out. It's gone.
Are we doing this tomorrow, or is this is all we do?
This is all we're doing tomorrow.
So if I finish it all tonight, I can just plan on
Yeah, wait.
Yeah?
So much time in class tomorrow.
We do. So I need to figure out what we could do tomorrow, maybe to.
trophies I can get.
No?
I think just this is A-okay.
Okay.
I don't know, as soon as
So I don't care what. Let's work a few more together.
Agreed.
On the first page there, anything look?
I don't know. Some of these are just like.
A lot of them are just normal factoring. 14. All right.
15 or 16.
Just take out the 12.
Wait. What do you want to take out on 14? Hold on. Let's look at.
12 in.
You guys, hold on. You keep saying take out 12 on 14, and I don't know how you're going to take out 12 from 28.
We take out 4 in.
Let's take out a 4 and an M. Yes, let's do that. 6n squared plus 7m minus 3. What? That just got a lot easier.
Yay, shoot, it's like a normal factor. It is. Oh, shoot. Except for
This is just factoring.
Yep.
hold on.
Let's see. It's got to be 1 and 3
Where's you 1 and 3? What?
on the back end. Sorry, for the 3, it's got to be 1 and 3. For the 6, I've got options.
One of them has to be a negative.
It will have to be negative.
One of them.
One of them. Probably the 1.
Probably the 1, since the 7 is positive. So that's. I should probably be doing this in pencil rather than 10. Oh, but I see it. I see it. Factors of 6.
2 and 3.
3 and 2 or 2 and 3. What do I want to cross from the 3?
3.
The 3, that would be 9, and then 9 minus 2 would be 7.
This is just time consuming.
Again, just trying to get you up to 20,000 as well. That way you'll be as good as I am.
Even out the playing field. I'm just gonna wait.
What's that?
Alright, I'm just gonna start doing 1.
Let's see. What else looks crazy? Anything?
15 or 16. Those are both kind of nasty.
47.
18. 243.
Oh, yeah.
Oh, I didn't even think about the bag. The bag was always already.
Well, but we'll have all the factories tomorrow. Plus an answer from Friday.
18? I could do 18. Let's do 18. We'll do some more. Alright, we'll do 47 in a minute. Oh yeah, y'all are overthinking 47. Number 18. So what can I... GCF first. Always GCF first.
I really feel like a 12.
Definitely a 3 and a B.
Oh.
Right. The rule is 2 plus 4 plus 3 is 9. That's divisible by 3, so 243 is divisible
Now,
by
what
3.
is 241?
Yep, 81.
So I've got 4a squared minus... What did you say it was?
I don't know.
81.
They're both perfect.
Oh, we are not done because those are both perfect squares.
So it's
2a
minus
minus
9, 2a minus 9.
2a plus 9, 2a minus 9. With the 3b out front. Yeah, that's correct.
So that one was as hard as I thought it was.
I think most of them are going to end up like that. They look terrible, and then you take out a GCF, and you're like, oh, well, that's not really so bad. But you want me to look at...
I don't know what I would be overthinking on this one.
47. Is there something in common to both? Oh, C plus D.
So it's just C squared.
So let's take out C plus D. How many C plus D's can I take?
One.
Just one. This has one yellow triangle, or 3 yellow triangles. This has 1 yellow triangle. So I will factor out
Oh, now it's just
1 yellow triangle.
C plus B minus 4C.
Wait, is that a triangle or is that
Rectangle, sorry. I don't do geometry. It's been a while since I've
What's
taught
that?
geometry.
Minus 2C plus 2B.
So if I took out
CD squared.
C plus D squared, because I took one of them, now 2 of them are left.
4C.
CD squared
AC.
minus
Oh.
minus 4CD, because I took out the C plus D.
There is not an answer to this school. Sorry.
Dr. Pride.
I'm not cheating, I'm trying to check my answer.
I don't think that's it, because if I FOIL C plus D,
You get C,
what do I get?
C squared plus C.
C squared plus 2CD
2C.
plus D squared minus 4CD.
That's a lot of extra numbers.
Why is so many
Is there any like terms in there?
Well, 2CD minus 4CD, so
So
big
negative
negative 2CD.
I still have the C plus D out front.
I don't think we were over.
Yeah, I don't think we're overthinking.
How about C squared minus 2CD plus D squared?
C, wait, what? C squared minus 2CD.
That will factor.
Oh.
We're going to the next
Can you give us
problem.
more
Is that C plus D minus 2C?
Wait,
why are we doing more? 2D.
It's C minus D and C minus D.
Was that top one not the factor? Okay, the word, what?
I really wish.
Mr. Wolf, I don't think we are overthinking.
No, yeah, you didn't overthink that one. That's fair. There's that C plus D that went along for the ride the whole time.
Yeah, will that be on the way?
I'm so lost.
Short number 50 is X to the 12.
My parentheses look like C's and my C's look like C's.
Yeah.
That's fair. You good with 50 and 51? Those, I mean, 12A looks bad, but what format is number 50?
Cube. No.
Is there something cubed that gets to 25? No.
So
Is there something squared that gets to 25?
Yeah.
Is there something squared that would give you X to the 12A?
Maybe.
Why don't we just do 50?
But let's just do it
Then
right
what if
now.
the A gets squared?
Let's see. Power to a power you multiplied. So what squared would get me to
Well,
X to the 6A?
what? So A would be squared.
So if square root is just
That's not
about
Because X to the 6A times X to the 6A
Because you add
That makes sense.
would be X to the 12A, because we add them.
That's right.
51 is similar.
That's the finished.
49 is
factor,
similar.
right?
Yep, that's as good as it
I
gets.
gotta pull out some random parentheses.
Wait, we said 49 is what?
Good. 49 is
That's
a
just
lot of
C2 and
Is 49 done?
No, 49 is not
we've
done.
been doing this for about 10 minutes and we've got full
You take out
There's nothing I can
I'm
take
not-
out,
I'm not doing this. Why? Oh, yeah.
but it looks like I could maybe do something like that with it.
So it's B4A.
Oh, there's 3, negative 3.
So, yeah, minus 3 and minus 3. And what times itself will get me to B to the 8A?
4A.
B
B to the 4A? Or just,
Yeah, B to the 4A.
these are factors.
Wait, but what about the?
So what do you get?
Oh wait, never mind.
They
Oh.
figure it.
Oh.
Figure it out. I'm not.
Yeah.
This is mine.
Isn't C, P, and
I will
PC the
not be
exact
playing
same
Brawl
thing?
Stars in class.
This is easy for me.
For 43, can we just combine 2 CP and 21 PC?
So much.
You could, but I bet they have it set up so that you
We can
could,
group.
you can group on 43.
Oh.
Cool.
So you're right. You could combine those two in the middle, but I bet it's easier if you leave it as is and group.
How do you group?
Oh, you take out of the groups and they're supposed to equal like the same.
And hopefully your leftovers are the same.
If they're not, it's no solutions, right?
If they're not, we did something wrong. But
No factors.
I think I see that one is going to be the same leftovers.
Yes, you just take out C.
You just know. He's done this problem probably 40 times.
That's my first time doing this problem, but I can take out a C in my head. I'm that good.
Wow.
I know, right? And then on the second term, I can take out a
7.
7P.
7P.
P. 7P.
Wow. My front's much nicer.
Yeah, in fact, those two rows are factored by grouping there. And the previous 3 rows are.
Oh, we have English test.
I'm so glad I dropped advanced English.
All right, your brain tapped out for now. We'll do some together tomorrow.
Have review of this mechanic, because like I'm not helping y'all with all this stuff yourself. She gives us
Oh, she gives you that's